Okay, good evening, ladies and gentlemen, and welcome to this day two of Lean Six Sigma Black Belt Certification Hackathon. How are you? In one word, can you just describe your state of mind? Type in the chat box. How are you? Energetic, exhausted, tired, superb, amazing? Just give me in one word. Great, exhausted, awesome. Okay, fantastic. Excited, okay. Loaded, okay. Okay, I can understand. I can understand. You guys are amazing, awesome. So, despite of all these challenges and your routine office loads and your household responsibilities, you are learning this. Okay, that's a fantastic thing. So, let's do one thing. Let us start our session with the simple this one. Our what we say that uh, revision, right? Revision. Okay, so whatever we have seen, just run away from office. Okay, so whatever we have seen yesterday, okay, can we just quickly type randomly the topics what we have discussed yesterday so that we can take it forward. So today we are going to cover the advanced hypothesis and advanced regression. Okay, so all the forms of hypothesis testing we are going to cover today with practical with Minitab. Okay, चलिए what we have covered yesterday, type in the chat box quickly. चलिए फटाफट टाइप करिए. Randomly you can, sequence may not be required. Central limit theorem, very good. So how to generate the data we have seen. Then we have seen central limit theorem, MSA measurement system analysis, GRR, AAA, GRR value, kappa value, NDC, number of distinct categories, very good. Normality testing, superb. What else? SNC, stability, normality, capability. And then transformation, if the data is normal or not normal. If it is not normal, then we go for transformation. Before transformation, see, transformation is just like a surgery. So transformation has to be done if required. It's the ultimate thing. Like for example, whenever we have some disease, so the doctor does not directly suggest the surgery, right? So first they give some medicine, check whether it can be cured by the medicine, some exercises, etc. Okay, if it is not, maybe they change it. Okay, so similarly in this transformation thing, whenever we come across the non-normal distributed data, then first there are three steps I suggested yesterday. How many of you remember that? Three steps. You do not directly jump to the transformation. First, what you do? First, what you do when you come across? Bolo, bolo, bolo. Remove the outliers. Fantastic. So first you remove the outliers. The extreme values ko remove kar do. Second, increase the sample size as per the CLT, which is central limit theorem. Yesterday we have seen that. As we increase the sample size, we generally get the normal distribution, correct? So increase the sample size, that's the second option. The third option is, even if then it is not getting cured, then you go for transformation. So yesterday we have seen Box-Cox transformation, where we put the data in the Box-Cox transformation and we check which value did we check. Which value was that? Type in the chat box. Do you remember that value? Lambda value, exactly. It is lambda value, right? So we check the lambda value and our lambda value was 0, correct? So when the lambda value was 0, it was a log transformation according to the table given, correct? Right? So we did the log transformation, correct? So we converted that all the data points into log data and then we checked the normality and we found the normality. Now, how do we check the normality? Type in the chat box. Which tool do we use to check the normality? Yes, type in the chat box. Which tool do we use to check the normality? बोलिए. और उसी से हमारा आज का सेशन भी शुरुआत करते हैं. Yes, Anderson-Darling normality test, AD test, right? It was Anderson-Darling normality test. The two statisticians' name has been given, Theodore Anderson and Donald Darling. So these are the two statisticians. They just invented this test of normality. Now we put the data in the Anderson-Darling normality test, and if the p-value is greater than 0.05, right? So we spoke yesterday about this normality test. Okay. Now everybody knows hypothesis testing, yes or no? Yes, everybody knows hypothesis testing. Just type yes or no in the chat box. सबको पता है? Correct? Hypothesis testing पता है सबको? Null hypothesis, alternate hypothesis. Correct? So normality test is also a hypothesis. Normality testing is also a hypothesis in which the null hypothesis says data is normal, and alternate hypothesis says data is non-normal. Okay. Now we put the data in the Anderson-Darling normality test, and then we find that the p-value. Okay. You remember the rhyming, right? P low, null go. Everybody please type P low, null go in the chat box. Okay. So remember this rhyming, P low, null go. This is a very standard rhyming you have to remember. Clear? P low, null go. Yes. Now, so when we check the p-value, if p-value is less than 0.05, in that case, null go, right? We have to reject null hypothesis. So reject null hypothesis like this. So data is normal, we have to reject, and that means we say that data is non-normal. Are you understanding? And in case of p-value is greater than 0.05, that means, okay, when the p is high, okay, so we cannot reject null hypothesis. You have to accept null hypothesis. So whenever the data is, the p-value is greater than 0.05, then we accept the null hypothesis, or we say that failed to reject. In the statistical terms, it is called as failed to reject null hypothesis. It's the same thing, but in a different way. Okay. So data is normal. Are you clear with this? So normality test is also a hypothesis testing. Super clear hai ye? Just give me yes in the chat box. Clear? So yesterday we have seen normality test, and today we are going to talk about hypothesis testing. Okay, now everybody, since it is a black belt hackathon, so I believe that everybody is aware of hypothesis testing. Just give me yes, just confirm my statement. This is my hypothesis that you know hypothesis testing. Please confirm my statement. Yes, everybody? Yeah, this is my assumption that since you are at the black belt level, you very well know hypothesis testing, correct? At the basics, at least. Null hypothesis, alternate hypothesis, P low, null go, what is the probability value? Now let's talk about how this P value, yes, test this assumption. that I'm going to do it in the examination which will happen tomorrow, okay, for the black belt people. Anyways, coming back to this normality test. Now, let me give you a practical example. How many of you would like to know how this p-value is calculated? Do you want to know how this p-value is calculated and want to check manually? Just give me yes in the chat box. If you're interested, I can give you a simple example of this. Yes, fantastic. चलो ये p-value क्या है जिसको decode करते हैं. Let's find out the p-value which is probability value. Okay, I'll give you an example. Now there is a company, okay, and yes, the manual calculation exactly. Now there is a company, and which they use the carton boxes, the boxes to pack their product. Okay, so whatever the product, let's say if we purchase some television set or a AC or a refrigerator. So whatever the carton, no, it comes in the carton, right? So that carton we are talking about. Okay. So there is a vendor. Which basically is the carton provided for a company. Okay. So let's write down. So he generally produces. So there is a standard given to him. The standard average or the standard mean is equal to 1.84 kg. That means every carton, the mean, the standard should be 1.84 kg. The weight of the carton should be 1.84 kg. Okay. So what they do, those people, the purchase people, how many of you are from purchase? How many of you are from procurement, incoming inspection? कोई है यहाँ पे? Anybody in this department? No, right? Okay, so all right. So Sachin ji is there. Ismail, Mr. Ismail is there. Fantastic, super. So now there is something called incoming inspection, right? So the company engineers basically, what they did is they selected some samples. Okay, so the sample size here, they selected 64 cartons, 64 boxes were selected, and then they took the weight of all the 64 cartons, and the weight, actual weight, the actual mean, you can say the average. Okay, so I will write X bar. It's coming at 1.88 kilogram. Make a note of this, everybody. So this is N, number of data points N, and this is standard, which can be denoted by mu. Okay, mu. And they check the standard deviation as well. They check the standard deviation of the data, and the standard deviation of the data is found to be, so sigma, which is standard deviation. Let me just remove this. So the standard deviation of the same data of the 64 cartons found to be 0.3 kg. Okay, so let me repeat. So we have a vendor who is supplying the cartons, the boxes, and the standard given to him is 1.84. Okay, so the engineers took the 64 cartons, the sample, and they took the weight, which found to be 1.88 kg. So actual weight is 1.88 kilogram. The standard is 1.84 kilogram. So there is a gap of 0.04 kilogram, and the standard deviation is 0.3 kg. Clear, everybody? Just type yes in the chat. So scenario, have you understood? Let's understand whether there is any statistical significant difference. Clear? Scenario, are you clear with the background scenario? Just type yes in the chat box. Everybody clear? Just give me yes. Very good. Now open any. First, we will do it in the mini tab. Okay, let's do this. Let's do this with manual. Okay. First हम लोग manually करेंगे, and then we will do it in the mini tab. Okay, chalo. So let me just once again go back here. ठीक है. So the formula, the first what we will do is, first we will do a Z calculation. Okay. So calculated Z value we will do. So the formula for Z calc is equal to X bar minus mu divided by standard deviation divided by square root of N. Okay. Everybody, X bar minus mu divided by standard deviation divided by square root of N. So everybody has got these values, right? What is X bar? X bar is nothing but 1.88. Correct? Minus mu is equal to 1.84. Can you just pull out your calci and give me the answer for this? Standard deviation is 0.3 divided by square root of 64, which will be 8. Correct? Can you just give me the answer for this? Just type in the chat box quickly. Calculate this and give me the answer in the chat. Yeah. Once you have done it, let me know in the chat box. Done, done, done. 1.06, 1.0666, right? ऐसा कुछ तो आएगा, correct? 1.0666. Yeah, so we can just round it off to 1.07. All right? Everybody got this answer, 1.0666. So 1.0. So we'll round it off to 1.07. Everybody got this answer? Just give me yes in the chat box. I'll wait for your confirmation. मिला सबको आंसर? आप एक्चुअली एक बार करो, ये खुद करो, so that you will understand what is p value. And anyways, in this with this software, we need not to do it manually, but at least once at a black belt level, we should understand at least once. Okay. Done. Everybody done with this? Just give me yes. Yes, no. Can we change the sample size 64? No, right now just stick to this. Let's understand this. Then you can do whatever with some number you can play around. Okay. Yeah. See, sample size 64 is clearly yeah, because you can easily calculate square root, etc. Okay. Now I have just given you a statistical table. Can you just download that statistical table? So that statistical table is for all various distributions. Okay. Now we are going to learn 4 distributions. What are those 4 distributions? The first one is called as normal distribution or the Z distribution. The second one is T distribution. They're like 1 sample t-test, 2 sample t-test, pair t-test. Okay. And then F distribution is also there, where we are going to compare the variances. Okay. Where I will cover the F distribution, and whenever we are going to cover the proportions, the comparison of proportions, then we will go for chi-square. So there is chi-square distribution table also given. Now, similar to our log tables, like we used to check, this is the statistical tables where it is the area under curve. I'll show you that. Just scroll it down. Just scroll it down. Now this is nothing but the area under curve. Okay. Everybody have opened this? Let me just increase a little so that you guys can easily understand. Okay. Chaliye. Now this is, now all these diagrams. So for example, the Z calculated value, which is 1.07, okay, is basically this value. This value. ये जो line है ना. So whatever table is given, okay, so this is the Z calculated value we have done. And this table is showing the area on the left hand side. Okay. For example, let me give you example. Let's say if the Z value is, this is a Z value. This is up to the first decimal. After that decimal point, the first digit. If the Z value is 0.11, imagine the Z value is Z calculated is 0.11. So I have to check 0.1 idhar hai, and then 1. Can you see this? This one, 0.1 and 1. So second digit is here. So the first digit you have to see on the vertical side. The second digit you have to check on the horizontal side. Okay. So here you will find this. That means 0.5438. That means this area under curve is 54.38%, which is nothing but 0.5438. Clear? So this is nothing but these numbers are the area covered under the curve, which is calculated ready-made to us. And this entire table is basically coded in algorithm of the software. That's why software directly gives us the answer. Clear, everybody? Just give me yes in the chat box. Now, what is our answer? 1.07. So let's find out 1.07 here. So you can find out here 1.07. So 1 is here. Look at this line. Okay. And 0.7, look at this line. So whenever they are intersecting, if you see this, so this must be the answer, right, everybody? 0.8577. Clear, everybody? 0.8577. And this is called as alpha value. This is called as alpha value. The p value is equal to 1 minus this alpha value. Okay. So p value is equal to 1 minus 0.8577. So it will be something like 0.143, something like that. And this is our p value. Clear, everybody? So we are calculating three values here. First, we calculated Z calc. Then we calculated alpha value. And from alpha value, we have calculated p value. So this is a sequence. Z calc, alpha, and p value. Clear hai? Just give me yes in the chat box. Everybody got this answer? Just give me yes, confirmation. Any doubt? Clear? So let's do this. Let's do this with the help of Minitab. Just open any blank Minitab worksheet. Open any blank Minitab worksheet. I'm just opening one worksheet. You can open any blank worksheet right now. Okay. Once you have done, just type done in the chat box. Yes, opened. Just type open in the chat box, guys. So I have opened one file. You can open any blank file, okay? No, this, let's forget about data. Data की जरूरत नहीं है अभी. Let's data is not required. Only blank worksheet is required. Data I have not yet shared with you. वो ANOVA वाला फाइल मैंने ओपन किया because it was in front of me, so I've just opened it. You can open any blank file or any file with the data. It doesn't matter. Blank file होगा तो अच्छा होगा आपके लिए. ठीक है? Opened, everybody? Just give me yes. Just type yes in the chat box. Open in the chat box. Super. Now let's go to stat, basic statistics. Now there is something called one sample z-test. Now you will be surprised. Why one sample z-test? We have only studied one sample t-test, right? So what is one sample? Whenever your n is less than 30 data points, we go for t-test. Okay. And when your n is equal to or greater than 30 data points, then you can go for z-test, where if you remember, as we increase the sample size, okay, now what is t and what is d, what is z? They are similar kind of distributions actually. So t distribution is a little flatter distribution like this, where, even if you have less data points, for example, in lot of cases, you cannot have those many samples. आपके पास उतने सैंपल्स नहीं होते हैं बहुत सारे केसेस में, इन दैट केस वी यूज टी टेस्ट, okay, which is very very important test for, that's why in the green belt level we have understood one sample t test, two sample t test. Now after this we are going to understand paired t test as well. So in all these aspects a t distribution is used. See, t distribution is similar to normal distribution. So if you increase the sample size, if you increase the sample size of t distribution, generally it takes the normal distribution shape or the z distribution. That's the only difference. Clear? That's why, because n is equal to 64, it is much greater than 30 data points. So we are using one sample z test and correct? Super. Now, very good. Sample size for LSS study. So yes, we calculate the sample size for LSS study, and which is another topic. Okay. But generally, there are sample size formulae which are already covered. For example, one of the very simple formula is square root of n. So let's say you are making 100 pieces, take the square root of that. That means at least take 10 pieces to check your quality. Okay, so those kinds of formula you can use. Okay. Now coming back to basic statistics, one sample z test. Okay, now what we have to do is select summarize data, because we don't have data right now. Whatever data we have to input the data. Okay, हमारे worksheet में data नहीं है. Just select the summarized data here and put all the 4 data points, whatever we have suggested. So select the summarized data. Sample size is 64. Just put 64. The sample mean. So whatever actual sample mean was 1.88 kilogram. Okay. Known standard deviation was 0.3 kilogram, if you know that. And perform hypothesis test, which is hypothesized mean or the standardized mean, was nothing but 1.84. Everybody with me, just type yes in the chat box. Put all the 4 data points. Sample size was n. Sample mean was x bar. Standard deviation was 0.3. And mu was standardized mean or hypothesized mean was 1.84. Okay, don't click OK yet. Go to option. Now here also there are 3 alternatives. What are the 3 alternatives? Mean is less than hypothesized mean. Mean is not equal to hypothesized mean. And mean is greater than hypothesized mean. Now in our case, the mean, which is 1.88, is greater than hypothesized mean of 1.84. So we will select the last option called actual mean is greater than hypothesized mean. Are you clear? Just type yes in the chat box. So we'll select this option and say OK and say OK. Wow. Now look at this. Everybody got this answer? Just type yes in the chat box. Just give me yes. Just give me the confirmation. I'm just waiting for you guys. Do you want me to repeat? I can. Fantastic. Super. Nitesh has got it. Who else? Got it, everybody? Just give me the confirmation. Very good. Now you will understand this. N is equal to 64. N is equal to 64, which we have already understood. Mean is 1.88, which is x bar. Standard error of mean is nothing but sigma divided by square root of n, which is 0.3 divided by square root of 64. इसका आंसर है ये standard error of mean. What we calculate is z calc 1.07, and then the p value is equal to 0.143. Everybody got this? Just type yes in the chat box. Clear है now? This is what we calculated manually as well. And software has given us quick answer because all the tables are already, already fitted in the algorithm of Minitab. So it calculates it and gives us directly answer. Clear hai? Just type yes in the chat box. So you understand how the p-value is calculated. Yeah, Sridharji, you want me to repeat the process? I'll just quickly repeat the process as well. Go to stat, basic statistics, one sample z-test. Okay, here in the drop down menu, you select the summarized data because we don't have any worksheet data right now. So we put the data, sample size is 64, which is n. Sample mean is 1.88, which is x bar. Known standard deviation, which is 0.3 sigma. And hypothesized mean, which is the standardized mean, whatever is 1.84. Okay, then we went to options and selected, because our actual mean is greater than hypothesized mean, we have selected the third option and we clicked on OK, and then we clicked on OK, and then we got this answer, one sample z-test, where already we have calculated the z value, z calculated, as well as the p value. Clear? This is how software also has calculated the same way. Clear hai everybody? Just give me yes in the chat box. Super clear? Yes, yes, yes. Clear hai na abhi? Very good. Now, so everybody is clear with one sample t-test, two sample t-test, right? सबको याद है one sample t-test, two sample t-test? Yes, no? याद है ना ग्रीन बेल्ट में किया था? See, if you are not gone through the entire green belt content, it's okay. But if you're very new, it's okay. But if you are already a green belt certified, if you have already coming to a black belt hackathon where you are supposedly have gone through the black belt content as well. Okay, correct? Correct? Remember ना? Very nice, very nice. चलिए, so हम लोग आगे बढ़ते हैं. Right? One sample t-test, when do we use? When we want to compare one sample with a standard, that is called one sample t-test. It is exactly like one sample z-test. Okay, here we have used z table, there we use t table. Correct? When the sample size is less than 30, maybe 20 or 15, then we go for one sample t test. Then when do we use two sample t test? When two groups have to be compared with each other, that's where the averages have to be compared. We go for two sample t test, right? So let's go for the next one, which is called pair t test. Pair t-test. Now, what is pair t-test? Let's download this file. What is the main difference between one sample and a two sample? Is this the main difference between one sample t-test? So let's say, for example, if the vendor, okay, the vendor data, like what we have done now, there was only one vendor, correct? And that vendor was providing the boxes. So we have collected 64 boxes, took the average 1.84 kg, and that average X bar was compared with the mu, which was 1.88 kg, the standard. Okay, so standard was mu. So the null hypothesis will say X bar is equal to mu, and alternate will say X bar is not equal to mu. Okay, and this is called one sample t-test when you are comparing one vendor with a standard. Now, if you want to compare two vendors with each other, vendor 1 and vendor 2, so it's like x1 bar and x2 bar. This is the null hypothesis, HO, which is null hypothesis. Will say the average of vendor A and average of vendor B are same. And alternate hypothesis will say there is a difference between average of vendor A and average of vendor B. And this is called two sample t-test. Clear? This one is one sample t-test and this one is two sample t-test. When the n number of data points are less than 30 data points. Then we go for t-test. Clear? Ismail ji, are you clear with this? Just give me yes in the chat box. सुपर. तो आपका भी ये हो गया. क्लियर है ना? Just give me yes. Clear now. Very good. Fantastic. Super. Now, so the next one is called as pair t-test. Now understand the pair t-test. Similar to two sample t-test, whenever the common sample is tested against two scenarios. I'll give you a couple of examples. Okay. A person's weight checked against old weighing balance and the new weighing balance. The person is same, the sample is same, checked against the two various equipments. It is called pair t-test. A blood sample is taken, checked against old analyzer and the new analyzer. It is called pair t-test. Are you understanding? The same person. Okay. So let's say call center employee. If call center employee worked for 1 month under one boss and the same call center employee worked under second boss, then comparing that will become a pair t-test. Are you clear with this? Because the sample is common, tested against two scenarios. Have you got this idea? Just type yes in the chat box. Have you got this idea? Just type yes in the chat. Pair t-test समझ में आ गया? So here you can see the specimen which is checked against old analyzer and the new analyzer here. Okay? So once the fundamentals are clear, then the hypothesis testing becomes very, very easy, simple. Okay. So right now what we will do is go to stat, go to basic statistics. Now the first one is one sample Z, one sample T, two sample T, and below that there is something called pair t-test. Just select that. Now in the drop down, there are two options. Each sample in its column, and the second is summarize data. Okay, because we have the data in front of us, so we'll select the each sample in each column. So sample 1 we will select old analyzer. Sample 2 is equal to new analyzer. Okay, and go to option and don't do anything in option. Just say okay. And here we go. What we are interested in is this. The p-value, which is Acha, screen is not moving, huh? Okay. Just a second. मैं फिर से करता हूं. I'm so sorry for that. Okay, so everybody got this file now, old analyzer, new analyzer. Just give me yes in the chat box. Everybody got this file downloaded? Pair t-test. In the chat I've given, right? Just click on the chat. It will get downloaded. All right. So I've just shared it once again. Okay. Now, these are the blood samples which are analyzed in both the analyzer, old analyzer and the new analyzer. Okay. P-value is 0.08. So let's go to stat, basic statistics, and pair t-test. Everybody follow this path. Stat, basic statistics, pair t-test. Click on that. Each sample in its column, select the same one. Don't change anything. In sample 1, select old analyzer. In sample 2, select new analyzer. And click on OK, and you will get this value. Okay. So if you get it, p-value is equal to 0.003. So here, so what is the null hypothesis here? Null hypothesis is the X bar new is equal to X bar old. Okay. And the old hypothesis says, the alternate hypothesis says there is a difference between new and the old analyzer. All right. So the p value is low. So p low, null go, right? So in this case, there is a statistical significant difference between the p value, between the old analyzer and the new analyzer. So उसमें ज़्यादा difference है, statistical significant difference, because we have to reject null hypothesis. Null go. P is lower than 0.05, right? Null rejected. Clear hai? Everybody clear? Just type yes in the chat box. So the path is this. Stat basic statistics pair t-test. Ye hai path. Neelam ji, just check the path. Stat basic statistics pair t-test. Once click on that, sample 1 में old analyzer, sample 2 में new analyzer. That's it. And click on OK. That's it. So आपको याद क्या रखना है? Stat basic statistics pair t-test. That's it. Clear? समझ में आ गया? So when we have the two samples, we go for one standard sample tested against two scenario. We go for two sample t-test. Okay. Give me yes if you have understood this. Done, guys? Super. Now we have seen one sample t-test, two sample t-test, one sample z-test, pair t-test. Okay. Now, whenever we have more than two samples, then we go for ANOVA. How many of you have attended default or not the other option? In alternative hypothesis, why we have chosen the default and not the other option? Now, we are not sure. Whenever we are sure about what is the difference between them, then we can select that. Otherwise, just say that is there is statistical significant difference. That's it. That is good enough. When we are not sure about what is the difference, because in the pair t-test, what happens is they check the pair difference between each and every element. So pair t-test is a little different than the two sample t-test. Okay. So in the two sample t-test or in the one sample z-test, we knew that 1.84 was was the standard, but 1.88 was the actual. So it was already more that we knew. But in the pair t-test, we did not calculate it manually, right? That's why we selected is not equal to. Okay. So generally, not equal to, see, it is called one-tailed test or two-tailed test. Okay. Whenever we are not sure whether it is less than or more than, just select the two-tailed test, which is on the both direction, it will show the defect. Okay. Whenever we are not sure about it is greater than or less than, then select the not equal to. That will be the better option. Okay. Super. Now let's go to our ANOVA. Okay, ANOVA. Last week में ANOVA का session किसने attend किया था? How many of you attended the ANOVA session last week? No, the good one is, so what we are selecting here is there is a statistical significant difference between both these analyzers. Okay. For example, let's say you want to compare two analyzer and want to check which, you want to basically want to check there is no much difference between both these. Okay. Because if you bring one machine, okay, you want the similar kind of performance to be done. But in this case, there is a difference between this and this. So you need to investigate why this difference is coming. Okay, so the difference between the paired values is much higher and it is statistically significant. That was this p-value is suggesting basically. Okay, so we need to investigate what exactly is making this difference. Okay, but there is a statistical significant difference between the old analyzer and the new analyzer. That is what it is. It might require calibration. You have to do the brainstorming. Okay, lot of things. Maybe measurement system analysis. Okay, so a lot of things we can discuss around that. Okay. And then after that, after calibration, after MSA, you can do this kinds of stuff once again. Okay. Super. Now, ANOVA, how many of you remember ANOVA? Yes. So need to fix one abnormal, or if let's say the new one is not giving the result, then we need to stop till the time it basically gives the result. Okay. Or if the old one is giving the faulty result, you need to discard the old analyzer. ऐसा कुछ तो करना पड़ेगा. But as of now, there is a statistical difference coming. Okay. Now coming back to ANOVA. Now I'm just sharing ANOVA file with you. And let's open this ANOVA file. This is the same file which we actually did the last week. Okay. And I suggested then to go for. Now, when do we use ANOVA? First, open this file, then I'll explain you. You're not getting any file? Okay, the people who are not getting the file here in the chat. Okay, see, there are a couple of things which you can do. One is your yeah, the Zoom updation. Okay, एक बार Zoom को एक बार update करिए. That is one thing. Secondly, I'm just showing you another way of getting those files. ये black belt के ही file है. Okay. Yeah, no issues. I'll just give you another option. जैसे कि yesterday मैंने बताया था, right? So go to the black belt curriculum, open the black belt curriculum. Let me show you that. Go to LMS, open the black belt curriculum. Okay. So this is the black belt curriculum. If you scroll down and you will find, go to analyze phase, hypothesis testing. So advanced hypothesis testing, look at this. So this is where, okay, let's say, for example, I've shared ANOVA file, right? So you can see ANOVA Minitab file. You can just click on start here. So you open the black belt course, go to advanced hypothesis testing black belt. In that, you will find ANOVA Minitab file. Just click on start and just download the file from there. Okay. So there are two files given here. See, these two files are Minitab files and these two files are the Excel files. Okay. Both files are different. You can just click on the left-hand side of the file and you can try this. Okay. Clear, everybody? The people who are not getting the files from the chat. First, you upgrade your Zoom. Second is, you can just download it from your course content as well. All right. चलिए. So अभी हम लोग जाते हैं ANOVA की तरफ. So ANOVA is what? So again, understand this. So when you have one sample, comparing one sample with standard, go for one sample t-test. Okay, so it is one sample t-test. Then what is two sample t-test? When two samples are compared. Okay, and when do we use ANOVA? When more than two samples. The average of more than the two samples have to be compared. Clear? We use ANOVA. That means the average of one vendor, two vendor, three vendor. Let's say if there are five vendors and I want to compare the average of the five vendors, is there any statistical difference? Then I'll go for ANOVA. Clear? Hai? So this is a file. If you remember that day on our, I think one of our Saturdays, I believe, last Saturday or last to last Saturday. Okay. This example was given. So let's say there is a BMW showroom and there are 5 zones. Let's try to understand this. This is zone number 1, which is, let's say, BMW showroom number 1. And these are the averages of the service timing. Okay, servicing ka time for one BMW car. Okay, so they have taken five readings each. So for the second zone, these are the reading. For the third zone, these are the readings. So what software will do? Software will calculate the averages. Okay, so X1 bar, then X2 bar, then X3 bar, then X4 bar, and X5 bar. So all these 5 averages software will calculate, okay, separately. And then the null hypothesis will be, okay, all are equal. And alternate will be at least one average is different, statistically significant different. Okay, so this is where, when we are comparing more than two, go for ANOVA. Clear, everybody? The background of the data clear hai? Just give me a in the chat box. Once the p-value fundamentals are clear, then we can directly put the value in the Minitab and directly get the get the result. Clear? Just give me yes in the chat box. Super. Now here, what we are, so let's go to stat ANOVA one way. Everybody just follow this. Stat ANOVA one way. Okay, राजीव जी ने तो p वैल्यू भी निकाल दिया. Fantastic. So stat ANOVA one way. Just select that. In the response, select the lead time, and in the factor, select the zone or the service center. Okay. So what we are comparing here, the various lead time averages of various service centers or the zones. Okay. Once we did that, then click on OK. And we'll find this graph first. Everybody got it? Just type yes in the chat box. Super. Now the graph shows that the first one, so all the 5 averages are there. Okay. And these are called 95% confidence interval bands. Okay. Now let's come to, so the first one is around 5.3. Second one is around 5.43 or 45. Third one again is around 5.3. Fourth one is 5.26 or 27. And the fifth one is 5.28. Okay, so barring this one is a little higher than the rest of them. Okay, so graphically it is suggesting that there is a possibility of statistically significant difference between at least one zone. Okay, so let's go back to our sessions folder. This is our sessions folder. Click on the sessions folder here. Okay, and just scroll it up, and you will find out the p value here. The p value here is 0.018. Everybody got this value? P is equal to 0.018. So what is the conclusion here? What is the conclusion? How do we conclude with this p value? Yes? Is it lower than 0.05 or greater than 0.05? Is it lower or it is greater? Type in the chat box quickly. Lower than 0.05. So P low, null goes. So you have to reject null hypothesis, which says all are equal, right? So we have to reject that, and we have to accept the alternate, which says there is at least one, and which we know that zone number 2 has got more mean. Okay. Zone number 2 has got more mean. Clear hai? So now there are other statistics here. Like this is called ANOVA table. Okay, this is called ANOVA table. And I would highly encourage you guys to check this recording. Okay. Let me, in the masterclass archive, if you are interested, I'm just giving you the link from the masterclass archive. Okay, this is that recording from 26th of October 2024. We had taken a special session on entire ANOVA table decoding. Okay, so I'm just giving you the link here of your masterclass archive. Please go through that. That will absolutely give you super clarity about this, all the calculations. Okay, it is complete, almost 1.5 hour session of this calculations. So this is given in your chat right now. And what I'm talking about is this. Okay, this one is called as ANOVA table. ANOVA is analysis of variance. Okay, so zone number, degree of freedom DF, adjusted SS, which is sum of square, adjusted MS, which is adjusted mean square, then F value, and then P value. From F value, from the F table, we derive P value. So what is the formula of each and every, how do we calculate this? Each and every formula has been decoded. And below that video, you can find the Excel sheet where you can manually calculate this as well. Okay, would you love this? Just type yes in the chat box. So everything has been covered. Whatever is there, everything has been covered. जो भी statistics है इसमें. Correct? Please go through that. That will give you a lot of deeper clarity about this table. ठीक है? Super, super. So let me show you one table which will let us summarize whatever we have seen till now. So in the hypothesis testing, first of all, hypothesis testing is basically done. When do we use hypothesis testing? We use hypothesis testing when, fishbone cause and effect is done. After that, we do root cause analysis, RCA. And after that, to validate the root causes, we do hypothesis testing. Everybody clear with this? First, we identify the primary causes, then we identify the root causes, and then to validate those root causes, we do hypothesis testing. Okay, let's, for example, in that BMW example, the BMW service center. So according to the team, that service center, there is a difference of the capability or of the performances. So we collect the data and do the ANOVA, and we found that yes, service center 2 is performing not up to the mark and the average is very high. This is how the assumptions are validated with the hypothesis testing. So majorly that can be broken down into 3 areas. One is the hypothesis testing of the mean, which includes 1 sample t-test, 2 sample t-test, pair t-test, and ANOVA. So 1 sample with the standard 1 sample t-test, 2 samples with each other, 2 sample t-test, pair t-test, the sample is common, tested against 2 scenario, pair t-test, and if more than 2 samples, go for ANOVA. Everybody's clear till now? Just type yes in the chat box. Till now, everybody's clear? Just give me yes. Super clear hai yahan tak? Now let's go to the second option, which is called variability. Now, what is variability? Now, if you see the distribution like this, there are 2 aspects. Okay. One is called the central tendency. Let's say, which is X bar, mean mode median. Remember central tendency, mean mode median? Everybody just type yes in the chat box. Yes? Correct? Now there is another aspect which is called variability as well. Maybe the mean is equal, but the variability is different, right? So here, if we want to compare the variability of two, if I have two samples, I want to compare variability, which is standard deviation. Here we are checking central tendency, the mean, correct? Now, if I want to compare standard deviation or variance, which is sigma square or sigma, of two groups, like two samples, I will go for F ratio test. And if I want to check more than two groups, then I will go for test of equal variances. Variance is nothing but sigma square, correct? So this is another way of hypothesis testing. Now the third way is called as proportion. So proportion is nothing but if I want to compare the proportion. For example, let's say rejection data. Out of 100, let's say 5 rejected. That is a proportion, right? It is 5% rejection. Now let's say A shift has got 5% rejection. B shift has got 6% rejection. It is proportion. I want to compare A and B shift. Then I will go for test of two proportions. If I want to compare two shifts, I will go for test of two proportion. If I want to check more than two, which is three shifts, let's say A, B, and C, I will go for chi-square test. Clear? When it is proportion data, which the hypothesis testing has to be done, then two proportion test for two samples and more than two samples, go for chi-square test. Clear? Just give me yes in the chat box. So one is mean, other is variability, and third is proportion. These are the three areas where we have hypothesis testing. Clear hai? Just give me yes in the chat box. This table has been already provided in your black belt curriculum hypothesis testing section. Clear hai na? Just give me yes, no in the chat box. So now we will go for F ratio test. Okay. F ratio test को देखेंगे. And to check the F ratio test, so let me open the F ratio test right now. So now whenever we want to check the variation of two groups, okay, that's where the F ratio test comes into picture. So let me just share my screen for F ratio test. Okay, let me give you a scenario first, and then we will calculate the F ratio. All right. So F ratio test is, you can see here, let's say a random sample size of N12 and N2, N112 and N216. So there are two samples they have drawn from two population with a sample standard deviation S1 is equal to 145 and S2 is equal to 82. So here, maybe write this down. Now I want to compare the two variances. Now understand this. There are two samples. I want to compare this variation and this variation. Okay. So I have already given standard deviation here, right? So iska kya hai? N is equal to, for the first one, N1 is equal to 12 and sigma 1 is equal to 145. Sigma or S1. S1 is standard deviation. And the second one, N2 is equal to 16 and sigma 2 or S2 is equal to 82. Clear, everybody? So we'll put this data and check whether there is any statistical significant difference between the standard deviations of these two samples. दोनों के वेरिएबिलिटी में और स्टैंडर्ड डिविएशन में क्या डिफरेंस है? Is there any statistical significant difference? That is what, okay, we want to compare. Now let's go to any Minitab file. The same ANOVA file also you can use. I'm just opening the same file which we have used earlier. Okay, because anyways we have to enter the data manually. Okay, so just go to the data. Okay, the same file you can open. Video is stopped, is it? Is my video voice loud and clear to you guys? Because मेरे सामने screen है अनुष्का जी, which is showing perfectly. Okay, now it is fine. कभी कभी थोड़ा सा glitch हो जाता है, या इंटरनेट. Yeah, loud and clear. Fantastic. Super. Now, so what we'll do is, how do we do for F ratio test? Stat, basic statistics. And for F ratio test, basically, we are going for two variances like this. Okay, just open this. Stat, basic statistics, two variances. Please follow this path quickly. Done? Everybody with me? You can open any file, any blank file or the last ANOVA file also you can use, because anyway we have to enter this manually. Okay. Go to stat, basic statistics, two variances. Click on that. Now both samples are in one column. Just drop down and each sample in its own column, sample standard deviation and sample variance. So we have sample standard deviation, right, with us. So just select sample standard deviation option, the third option. Everybody, I repeat again, go to stat, basic statistics, two variances, because I want to compare. See, variance and standard deviation is one of the same thing, right? Square root of variance is standard deviation, correct? So just go for two variances. Click on that. In the drop down, select the third option, which is sample standard deviation. Now the sample one, what is the sample size? The sample size is 12 and the standard deviation is 145. I've just noted it down. For the second, okay, no. That's the difference. And standard deviation is 145 here. And sample 2, the sample size is 16 and the standard deviation is 82. Everybody with me till now? Just give me a in the chat box. Yes? We want to compare, is there any statistical significant difference between these two variabilities? Variation में फर्क है क्या? Statistical significant, right? Option में कुछ करने की जरूरत नहीं है. Just go to OK. Fantastic. So here you can see the p value is 0.043. Right? Everybody got this 0.043 p value? So what does it indicate? Is it higher or lower? Is it lower than 0.05? Yes, even though it is slightly lower, but still it is lower than 0.05. Correct? Very good, very good. So, see, what is p-value, guys? If you remember, I gave you the analogy, right? This is the sample 1. P-value क्या है? How do you visualize p-value? This is sample 1 and this is sample 2. Okay. ये जो बीच का रीजन है ना, the overlapping region is your p-value. Correct? If this overlapping region is, let's say, understand this, if this overlapping region is less than 5%, then there is a statistical significant difference. So let's look at this. Let's say this is 15%. Imagine this is 15%. That means the averages and standard deviation are very close. Okay. Now imagine there is something which is a little farther, where the p-value is very low. Here the p-value is, let's say, 2%. Whenever the p-value is less than 5% or 0.05, that means there is a statistical significant difference. Are you clear? So this way you can just visualize the p-value. For us, only check the p-value and infer. So p low, null go. That means there is a slight statistical significant difference between the variabilities of these two samples. Clear, everybody? Just give me yes in the chat box. Super clear है ये? This is called test of equal variances. Sorry, F ratio test, not test of equal variance. Okay. Now let's go to the next one. After that, it is already given in your, in your syllabus, in your curriculum. So you can anytime refer that. Okay. Let me just stop sharing and share it once again. Okay. So this is how it has been shown, the screenshot as well. Okay. Now, whenever you have more than two samples. Okay. Yeah. Pradeep ji, you have any question? Just put it in the chat box. Yeah, put your question. Please repeat. What do you want me to repeat? All this entire sequence? I repeat again. Okay. Now, what we have done, we went to stat and basic statistics, two variances. We want to compare two variances or two standard deviation, the same thing, correct? So, here we just put sample size n is equal to 12. Standard deviation, sigma is equal to 145. Again, sample 2, n is equal to 16 and sigma is equal to 82. So we are comparing whether any statistical significant difference between standard deviation of the two variances. Okay. So what we do is we just put the data and click on OK, and we get this p value, which is 0.043, which means p is low, null go. So null, what is null? There is no, so both variances are equal, and alternate will say both variances are different, correct? Because the p value is lower, we have to reject null hypothesis and accept alternate, which is there is a statistical significant difference between variance of first sample and variance of second sample. Clear? Clear hai na? Just give me yes in the chat box so that I can move for the next one. Super, super. Okay, now if you have more than, if you have the more than two samples, then we go for test of equal variances. Test of equal variances. So how do we do that? Yeah. So let me just share the same file. You can use the same file of the of that ANOVA वाला. Okay, ANOVA वाला same file आप use कर सकते हो. Can just open the same file. एक ही वही file use करेंगे हम लोग ANOVA का ही. The same file of ANOVA. Everybody got the same file, right? ANOVA में. Correct. Now in ANOVA, what did we do? In ANOVA, we compared between x1 bar, x2 bar, x3 bar, x4 bar, and x5 bar, correct? So all the averages were compared. Now in the test of equal variances, we are comparing sigma square, sigma 1 square, sigma 2 square. Understanding? So we are just comparing the variances of all the 5 groups. Clear? The difference between the data is same. Now we are just comparing between variances. Earlier it was the central tendency, which was the mean. Now we are comparing the variances. Are you clear with this funda? Just type yes in the chat box. Clear hai? Just give me yes. Note it down so that it will remain with you. Okay. Very good. Now let's go to stat, ANOVA, and test of equal variances. Just follow this path. Stat, ANOVA, test of equal variance. So when we did ANOVA first, it was one-way ANOVA, right? Now we are talking about test of equal variances. All right. So click on that. here. Okay, so response data are in one column for all factor levels, and response data are in separate column for each factor level. So response data are in one column only. So the response is nothing but the lead time, and the factor is nothing but the zone. Okay, everybody select that response and the zone, right? And just click on OK. Wow. Everybody got this? Just type yes in the chat box. सबको आ गया? Clear everybody? Just give me yes. Superb. So how do we read this? Yeah, how do we read this? Check the p-value. Okay, now the Levin's test is done when the data is non-normal. Okay, when the data is normal. So multiple comparison, 0.5. It is so both the cases, the p-value is greater than 0.05. So there is no statistical significant difference as far as the variability is concerned. See, understand this. In ANOVA, the p-value had failed. The test has failed for ANOVA. For the averages, there was a statistical significant difference for the averages. For the same data, the variation, the variability, there is no much statistical significant difference. Are you getting this idea? Just type yes in the chat box. Clear hai? So when we did the ANOVA with the same data, the test was statistically significant different, right? Because p-value was less than 0.05. Remember that? Correct? हम लोग करके देखते हैं अभी फटाफट. Stat ANOVA, one way ANOVA, if you remember, lead time और ये डाला था हम लोगों ने. Then we said okay, and we found that this was the p-value. Correct? You remember p-value was 0.018, which was lower than. But in this case, it was different. Correct? So in this case, if you see here, the p-value in this case is, यहाँ पे देखिए p-value is greater than 0.05. That means there is no statistical significant difference. And this is called test of equal variances. Clear? Just give me yes in the chat box. Clear hai? Everybody with me till now? Okay, now let's go to the proportion. So we have seen both the tests. No, it depends on what basically you want to test. Okay, it depends on, do you want to test the average difference, or do you want to check the variability? Both these cases are different, right? Correct? For you, the average is important, or for you, the variability is important. Let's say for example, your product demands a very stringent specification norms. Are you understanding? If your product demands a stringent specification norms, then you will better check the variability as well. Okay, correct? So basically it depends on what is your requirement. ठीक है? हाँ. So 11 test यहाँ पे लिखा है यहाँ पे देखिए. When do we use? So here you can see here, if the data is already normally distributed, we go for Bartlett test. And if the data is non-normal, okay, has not passed the normality, then we go for Levin's test. Okay, clear है? So आप उसको कर सकते हो, but in this point in time, p value is anyways greater than 0.05. So वो करके कुछ फायदा भी नहीं है. Okay. Now let's come to the proportion data. How do we compare the proportions? Let's open with test of two proportions. Test of two proportions. Okay. Now what is test of two proportion? Now let's say a corporation's purchasing manager need to authorize. Let me just open this. Yeah, so proportion data. So the corporation purchasing manager, a purchase manager is there, and who is to authorize the purchase 20 new photocopy machines. So they want to take the 20 Xerox machines. After comparing many brands in terms of price, quality, warranty, features, they have narrowed down two options, brand X and brand Y. Okay. So because they already had the machines of brand X and brand Y, okay, they just collected the data from their existing machines. What they collected? So random sample from 50 machines of each brand. Okay, it's a huge company, so 50 machines were there for each brand. So they collected data of 50 machines, and record indicates this. Okay, so what is the record right now? So right now, what they found was out of 50 machines, uh, what you can say 44 machines for the first brand was working fine. 6 machines required some maintenance. Okay. And the second brand out of 50, 42 machines are working fine. 8 machines require some kind of maintenance. So there is a proportion we are comparing here. Clear hai? Yes. So how do we go about this? Go to stat basic statistics to proportion data. Can you just open that quickly? Stat basic statistics to proportion data. Stat basic statistics to proportion data. मैं भी करता हूं आपके साथ ही. So with the same file, we can use the same file again. Go to stat basic statistics to proportion data. All right. Here it is summarized as select summarize data. All right. So number of events, meaning how many basically machines are running. Okay. So 44 machines are running out of 50 trials they have taken for sample number 1, and 42 machines are running out of 50 samples, 50 trials they have taken. So just put the data like this. Select summarize data because we don't have data in the worksheet right now. So whenever we don't have worksheet data, just select summarize data and put the data manually. Clear, everybody? And just say okay. And we want to compare is there is statistical significant difference between brand A and brand B. So say okay, and this is showing, look at this. So the first sample proportion is 0.88 and the second proportion is 0.84. So first one is 88%, second one is 84%, and want to check whether there is statistical significant difference or not. So p-value suggests 0.564. So when the p-value is 0.564, what does it indicate? Type in the chat box. The p is not low. So there is no statistical significant difference as far as both the brands are concerned. Okay. So let's just try to understand this. So whenever you are doing hypothesis testing, let's say this is, the under maintenance, right? So it is a maintainability you are comparing. The proportion of maintenance or proportion of maintainability you have compared. Now, there is no statistical difference between these two. Then you might go for the delivery, or you might go for the price. You might go for the quality. Are you understanding? So this is how you have to test one by one characteristics in the hypothesis testing. Clear hai, everybody? Just give me yes in the chat box. Super clear with this? Just give me yes. सबको आया ये? Superb, superb. Amazing. Very good. Now, after the two proportion test, the second one and the last one in the hypothesis testing is called as it is called as it is called as chi-square test, right? So when do we use chi-square test? Chi-square test is used when? Not able to see this. What is the short key of putting this into a presentation mode? Short key क्या है presentation mode को डालने का PPT को? F12 है क्या? Function F12. Function F12, is it? Okay, guys, let's do one thing. Uh, let's take a break right now for 10 minutes. It's already 8:28. And once we are back, then we will cover the chi-square test and the advanced regression. Clear, everybody? Yeah, there was a little glitch, but we'll just take a quick break. And once we are back, then we will just give me yes in the chat box if you are clear with this. We'll be back at 8, let's say 8:40. It's already 8:29, so 8:40 we'll be back. Okay? Once you are back, just type I am back in the chat box once you are back from there. Okay? Super, super. Okay, just type I am back in the chat box, everybody. If you are back on your seat, so that we can start the second half of our session. Super. So let me start the recording. Yeah. Oh, so chaliye. So see, anytime if you come across the recording is not happening, please let me know, okay? Because otherwise the other people will miss out on this. Okay, chaliye. So everybody, I am back in the chat so that I will get the confirmation. And let's move on to the chi-square test, which we had started just a little bit of. Everybody's back. I'm just waiting for your confirmation. So we are talking about the chi-square test, where we are comparing more than three, three or more than three proportions. If you want to compare, then we go for chi-square test. Now here, we want to know if the shift has any influence on the number of customer complaints. So number of customer complaint, again, it's a discrete data, and shift. There are three shift operations. So three shift and customer complaint data they have. So first we will understand how the chi-square test is done manually. Okay, then we will just quickly do it in the Minitab software. Okay. So here, what they have done is they have identified the defect wise customer complaints, defect wise, and the shift wise. Okay. For example, here you can see, let's say these are types of defects: defect A, B, C, and D. Defect A, B, C, and D. Okay. And A shift, it's like A shift, they have got 15 A type defect, 21 B type defect, 45 C type defect, and 13 D type defect, or the customer complaints. Okay. Similarly, second shift, these are the numbers, and the third shift, these are the numbers. Okay. Clear? Are you understanding what is the scenario here? So shift wise different complaints or different defects they are getting, and they have just put it in a tabular form. Clear? Hai? Just type yes in the chat. So whenever you are comparing more than two, so now in this case there are three shift operations we are comparing. So where we are using chi-square test. So here we are first calculating the expected value. Just observe how the expected value is calculated. Okay. Just pull out your calci and let's do this once so that you will understand it. Okay. So the first shift, so this is 15 plus 21 plus 45 plus 13. The row value, the row total is 94. If I add the row of the first shift, there are 20 total 94 defects we are observing here. Okay. When it comes to the second shift, 26 plus 31 plus 34 plus 5, total 96 defects or the complaints we are observing for shift number 2. And for the shift number 3, we are observing 190. So these are called row totals. So we are horizontally totaling it up, summing it up, and that is called the row total. Similarly, there is something called column total. So row total is the shift wise defect, and the column total is the, call it defect wise the complaints. Okay. So 15 plus 26 plus 33, it is 74. It's called column total. So this is the column B, 21 plus 31 plus 17, 69. Okay. Then column C, 128, and column D is 38. So the total, grand total is, if you either add the column total or the row total, both will add up to grand total. Okay. Now, there is something called expected value here. What is expected value? Row total. Now, can you just calculate it quickly? एक बार calculate करें. So, let's calculate the expected value for this 15. Okay. So, what is the row total here? 94. Let's look at this, what I'm doing here. I'm calculating it for the first value, which is first shift A defect, and which is 15. Okay. So the row total for this is 94 into the column total for this is 74. Can you just pull out your calci? 74. Okay. And divided by the grand total, which is 39. Sorry, 309. 309. Can you just calculate it and give me the answer? Type in the chat box 74 into 90 into 74, 94 into 74 divided by 309. Can you just give me the answer in the chat quickly? Simple calculation. 22.511. Is it everybody's getting the same answer? 511. Clear, everybody? So 22.51 is the expected value for this. So 15 is the actual value and 22.51 is the expected value for this particular value. Similarly, we will calculate expected value for all the data points. Clear? So all these 12 data points we have. So for all the 12 data points, we will calculate the expected value. Okay, now let us do this. Now, of course, we are not going to do this manually, but so this is, you can see, expected value for the type A defect for shift 1 is 22.51, which we have calculated. Similarly, so they have calculated expected value for each and every value here. Okay, so observed value and expected value. Clear? Yahan tak everybody is clear? Just type yes in the chat. So row total into column total divided by grand total, which is 309. Just give me yes in the chat box if you have understood this, how it is calculated. Now, anyways, I'm just explaining you how it is done at the back end. Just like we have seen how the p-value is calculated, right? Okay. So then the chi-square is calculated. What is chi-square? It is summation of observed minus expected square divided by expected. And this is called chi-square. It looks like X, but it is called chi. Again, this is a Greek letter, just like alpha, beta, sigma, delta, gamma, etc. Chi is also Greek letter. So this is the formula: observed minus expected square divided by expected and summation of that. So they have done this for us. Like for example, 15 minus 22.51, which we have calculated manually, square divided by 22.51. Okay, so observed minus expected, the difference ka square divided by expected, plus observed minus expected square divided by expected. So they have calculated this and sum it up, and this chi-square came to 19.18. So once this 19.18, they go to the chi-square table, okay, and they calculate the p-value out of it. Okay, now I'm just sharing the chi-square file with you guys. Recording is on, right? Yeah. So I'm just sharing the chi-square test file. Just open this file. Okay, once you have opened it, let me know in the chat box. The file is open. Okay, now we will do this with the help of Minitab. This is how we have seen how it is on the backend manually calculated. Now we will see with the help of Minitab how it is done. Once you have opened the file, let me know in the chat box. Done? Yeah, fantastic. Super. Chalo. So let's see the data. The same data basically. Okay, so same data which we have seen. Okay, this has been done in the tabular format. Okay, so here what we need to do is go to stat tables cross tabulation chi-square. Everybody? Stat tables cross tabulation and chi-square. Click on that. This window will appear. Everybody with me till now? Just give me yes in the chat box. I repeat again. Go to stat, tables, cross tabulation and chi-square. This option, the third option we have to select. Click on that. Now here just drop down. We have to select the summarized data in the two-way table because we have got the summarized data. Now which is summarized data? This one is summarized data, right? This one is summarized data for us. That's what we are selecting, the summarized data over there, okay? So we are selecting the summarized data over here. Now once we have selected the summarized data, in the column containing the table, just click on that and select A to D. Select A, B, C, D, meaning click on A, Shift and D and select. So A to D will get selected. And in the rows, select the Shift. This one, this column, Shift. Shift 1, Shift 2, Shift 3. Okay. Do not select Shift number. Huh? Shift number is another column. C1. हमको C1 नहीं select करना है. We have to select the C4 column, which is Shift column. Everybody with me? Till now, everybody with me? In the column containing the table, select A to D column, A, B, C, D. All you have to select. In the row column, just select Shift. Okay. Just let me check for the chi-square. Go to chi-square and just click on chi-square test and expected cell count. Okay, just select these two options in the chi-square. So when you go to chi-square, just click on chi-square test and expected cell count and click on OK and click on OK. Just go to the sessions folder and you will find this. Okay, the same table has been expanded. What we are basically is checking is Pearson chi-square value, which is 0.004. That is the most important value. The P is low. That means there is a statistical significant difference between this proportion, the data. Okay, the shift-wise data may statistical significant difference. What that means is 94. You can see here, shift 1 is 94, shift 2 is 96, and shift 3 is 119. So shift 1 and shift 2, there is no statistical difference, much difference as per se, but shift 3 has got some major difference. So we need to go deeper. What exactly is happening wrong in the shift 3? Why there are more customer complaints, especially in the shift 3 region? Are you clear? This is how statistically, the hypothesis testing of chi-square test can reveal the statistical significant difference between the discrete data. Clear? So this case, p-value is 0.004, which is much lesser than 0.05. So we can easily say that there is a statistical significant difference and we need to go deeper into shift number 3. Clear everybody? Just type yes in the chat box. Super clear hai sab kuch? Give me yes, no. Super. Amazing, guys. Any question? Yahan tak koi question hai? So this basically concludes our hypothesis testing, which is covered in the black belt level. Okay. हाँ जी. और क्या है हमें कवर करना आज? Let's go for regression and correlation today. Okay. Now so this is the advanced hypothesis. The basic hypothesis in the green belt we cover one sample t-test, two sample t-test. In the advanced hypothesis, we have covered one sample z-test, pair t-test, ANOVA, and F-ratio test, test of equal variances, then two proportion test, and chi-square test. Okay, so these are various hypothesis testing we have seen in the black belt level. Okay. Okay, now let's go to something called something called very interesting, which is one of the very favorite topic of mine. It's called regression. Okay, so regression क्या है? Let me share one data. Okay, let me share a file of regression here, which is, yeah, can you just open this file quickly? Just a second. हाँ जी, तो ये फाइल ओपन करिए, हम लोग रिग्रेशन करेंगे अभी. रिग्रेशन ऑलरेडी हमने सीखा है. विल गो टू द नेक्स्ट लेवल नाउ, which is advanced level regression. Okay, हम लोग एडवांस लेवल रिग्रेशन सीखेंगे. जस्ट सेकेंड. Uh-huh. Okay, I'm muted. Sorry for that. Okay, so you can go to black belt, and in the black belt you can check the regression analysis, and there are multiple files around that, so you can just check there. Minitab exercise scatter plot है, scatter plot patient and nurses, curvilinear regression. So इसमें से कोई भी एक फाइल आप उठा लीजिए. ओके, ठीक है जी. सुपर, चलिए. So open the file of regression. So as of now, this file says, so yesterday also we have seen there are, yeah. So this is temperature and expansion. Let's see what is this file all about. Okay. So this file is all about, there is a temperature given. If you remember, we used to do this exercise in physics. How many of you remember that? There used to be a metal ball, and there used to be a ring. Correct? Do you remember that we used to do this exercise? That this metal ball used to pass through this ring. Okay. After that, we used to hit the metal ball, correct, with the burner. And once it is heated, then it used to expand, right? The moment it expands, it will not go in the ring, correct? So similarly, there is a temperature given, and there is an expansion. They have just monitored, maybe there is a plate, and how much expansion the plate has. Okay, so this expansion they have measured basically. So temperature and expansion. So this is my x and my expansion is my y. Are you clear the funda? Just type yes in the chat box. Clear hai? So once they hit this, how much expansion it is observed in that plate, that is what we are basically checking here. So let's do this. So go to stat, regression, fitted line plot. Just go to stat regression fitted line plot. Now go to a linear expansion in the linear model, the linear model, which is, so your X is temperature and your Y is expansion. Okay, select your X, which is your temperature, and your Y is equal to expansion, correct? Just select that. And you will find this kind of graph. Everybody got this graph? Just type yes in the chat box. Super. But still this line is not, what you can say, fitting this model, right? The model seems to be a little curvilinear, but the line is the linear. So there might be a different model over here. Okay. Now look at this. So here, what is the equation here? Y is equal to A plus BX. Everybody knows this equation? Just type yes in the chat box. This is covered in the green belt level as well, right? So Y is equal to output. X is equal to input. A is equal to intercept. And B is equal to slope. Everybody knows this basics? This is that equation. This is expansion, which is our Y. This is our A. This is our B. And this is our X. Temperature is our X. Clear? And this is the equation for this regression. And along with that, the R square. If you remember, I gave you that R square values. So R square values, if it is between 0 to 35, lower strength of the relationship. 35 to 65, moderate. 65 above, you can say a strong correlation. So you can see R square value above 65, just above 65. But there is a curvilinear model fitting. Okay. So there is another option we can test, which is called quadratic model. Just go back to this. Just go to Control Alt D. Control Alt D. And go back to this sessions, go back to this window. Okay. Now instead of linear, just select the quadratic. Just select the quadratic. And say, okay, don't do anything else. Wow. Can you see the difference, guys? See the difference between the models. And see the R square value. From 68%, the R square has shifted to 87% now. 87.8, almost 89%. Have you got this? For the quadratic equation meaning wherever there are the square terms involved. Okay. So square terms meaning Y is equal to A plus BX. It's like B1 X1 plus B2 X2 square. B1 X ही लिखिए, X2 मत लिखिए. B2 X square. This is called, so let me just write it once again. So क्या होगा quadratic equation? Y is equal to A plus BX plus, so B1X and B2X square. This is called quadratic equation. Write this down. This one, Y is equal to A plus BX, is called linear equation. And this is called quadratic equation, where the square terms is there, X square. You can see here, temperature raised to square is there. Because there is curvature, there are square terms. Clear? Just type yes in the chat box. This is the equation. And R square is how good the model is fitting. The line of best fit is fitting to the data is the model. So from 68%, it has gone to 87%, which is a fantastic improvement. Let's go to another one, which is called a cubic model. There is something called cubic model. What is cubic model? Cubic model is nothing but, go to again, select the next one called cubic model and say okay. Now this is another model, which is a cubic model. You can see here. Let me reduce. Yes, this is called a cubic model, which is fitting even better. So let me write down here. Y is equal to a plus bx. It's an equation. And r square value is equal to 68.9%. Okay. Y is equal to a plus b1x plus b2x square, where r square value is equal to 87.8%. And here the equation is like this. Y is equal to a plus b1x plus b2x square plus b3x cube, and where r square value here is 96.9%, almost 97%. So this is the best fitting model, and we should take this regression equation for our calculation. Clear hai everybody? Just type yes in the chat box. Clear? So first one is linear, second one is quadratic. This is called a linear model, this is called a quadratic model, and this is called a cubic model. Just type yes in the chat box if you're clear with it. Everybody got these three graphs? So we can always check which model fits better, and r square value is our point. R square, if it is going the best, highest r square value, we have to select. As the model is fitting better, r square value will improve. Okay. Clear everybody? Just type yes in the chat box. What can we assess with the graphs? So what can we assess with the graph is, we are just checking the relationship between the temperature and the expansion. Okay, the temperature and the expansion we want to just select. So we collected the data and we want to check what is the strength of the relationship. And we found that the strength of the relationship is almost 97%. So temperature and expansion are very closely correlated. And which model is fitting? The cubic model is fitting the most. This is what we can basically check. Regression क्यों use करते हैं? Why do we use regression? To check the relationship between two variables, x and y. Correct? So this is the temperature and expansion. X is temperature and expansion is y. Want to check the relationship. What is the strength of the relationship? And the equation is called as prediction equation. Now within the range of the data, now we can predict exactly what if I given the value of x, I can easily predict the value of y with almost 97% accuracy. Are you clear? With this cubic equation, if you give me value of x, okay, I can, without actually hitting that element or article, I can predict the value of, the value of the, with accuracy of 97%. That's what it means. Okay. So now linear and cubic. See, linear meaning, for example, look at this. Linear meaning, there is only one line of best fit. You can see here, this is called a linear model. No? Only one. Linear meaning one line of best fit. It's called linear model. Okay. Quadratic meaning there are square terms involved in this, and there is only one curvature in the model. If there are multiple curvatures like this, you can see here there is one curvature here, there is another curvature here, then we can go for cubic. Cubic is x cube. So this is a difference between linear, quadratic, and cubic, which basically fits the model better and better, basically. Clear? As we use curvature, it fits the model better. Now you need to check all the three, and whichever r square value is the highest, that model you have to select. Clear everybody? Just type yes in the chat box. Clear hai? Yes, Sudhir ji, are you clear? Sridhar ji. Linear, quadratic, cubic का difference समझ में आया? So basically what we can do is we can select all the three and check which model fits the most. Check the R square value. Whichever R square value is highest, that is our best model. The regression is why do we use regression? First, to check. So there are two options, two objectives of regression. First, to establish, write this down. First, to establish relationship between X and Y. You remember yesterday I showed you positive relationship, negative relationship, and no relationship. Do you remember this? X, Y, and Z. Positive, if X is growing, Y is growing, it's a positive relationship. If X is going, Y is going down, it is negative relationship. If X is going, there is no impact on Y, that is no relationship. So first we establish the relationship. Okay. And second is the strength of the relationship. Strength of relationship. Okay. So between X and Y, what is the strength? And that is determined by R square value. Clear? So these are the two objectives basically we fulfill with the help of regression equation. First is establishing relationship between X and Y. And second, check the strength of the relationship, how impact X is making on Y. So when my R square is 97%, that means temperature is making almost 97% impact on my expansion. So expansion can be explained with 97% of accuracy with the help of temperature. Clear? Deepak ji, are you clear with this? So these are the two objectives of doing regression analysis. Super clear with this? Just give me a super. Amazing. Chaliye. Are you guys enjoying this discussion? Yes? Some deeper conversation, some interesting stuff, and some practical right away in front of you, along with you. You're also doing along with me. Yes? So that is the objective of doing this hackathons and the live sessions, so that you can go deeper. Otherwise, you can always go to the courses and check this. That will be enough to clear the examination. Okay, clearing for the examination ke liye courses are enough. But this is, we are going deeper because we want our understanding to deepen in every aspect of this. Yeah. Super. Thank you very much for this. Okay, now let me share one file which is called, now this is X and Y, right? One X and one Y. What about multiple X's? How about multiple X's? Can we handle multiple X's as well? So the answer is yes. So let me give you a file called, let's see how we can handle multiple X's as well. So there is a file I'm sharing that is called matrix plot file. Just open that file and then we will see how, if there are multiple X's, like just test of T. If test of T is depending on sugar and milk and water and tea powder, and there are so many multiple X's, right? How I can check multiple X's and one Y? That is called something called matrix plot. So let me just open matrix plot for you. Once you have opened it, let me know in the chat box. Once you have opened it, okay? Open. Super. Amazing. So let's try to understand this. Just try to understand this data. So here we have, there are four X's, X1, X2, X3, and X4, which is the tool aging. 1x temperature, speed of the machine, and experience of the operator. These are the 4 x's. Okay, the age of the tool. Okay, there is a, let's say, cutting tool is there, and this is called defect fraction, which is, for example, when it says 0.04, that means it is 4.1% defect rejection. Okay, when it says 0.0425, that means 4.25% rejection. Okay, so there are multiple x's, and this is the only y we have. So let's go for matrix plot. How do we do matrix plot? Go to graph, and the second option after scatter plot is called matrix plot. Just open that, graph, second option, matrix plot. Okay, graph, matrix plot, just select that. Select the simple one as of now. Click on OK. Now this is very interesting. Graph, second option, matrix plot. How do we select this? You have to select like this: x1 first, x2 second, x3 third, x4 is fourth, and the last one will be the y. This is the sequence you need to follow: x1, x2, x3, x4, and y at the end. Okay, so let's do this. So just click on graph variables. The first one is tool aging, x1, temperature, x2, speed, x3, experience, x4. Just double click on them. It will get selected automatically. And finally, you will select defect fraction. Double click on defect fraction. Everybody with me till now? Just give me yes in the chat box. Don't click on OK yet. There is a small thing we need to change. Yahan tak ho chuka hai. Everybody with me? Yes? Very good. Chalo. So look, let's go to matrix option here. Go to matrix option and just select, sorry for that, just select lower left. Okay, matrix display, lower left. Okay, lower left. Just select this. Go to matrix option here and select lower left and click on OK and click on OK. And here we go. You have got the matrix plot ready in front of you. Everybody got this? Everybody got this data? Super. Got it? Fantastic. Now let's read this graph. Now there are multiple graphs which can be seen here. Okay. Now understand, this is x1, tool aging, temperature is x2, speed is x3, experience is x4, and defect fraction is y. Okay. Now look at the bottom. That's why I've selected y at the last, because this is the graph number 1. This is a graph of x1 and y, which is tool aging and y. Are you clear? Graph number 2 is the graph of temperature and the defect fraction. Graph number 3 here is the graph of speed and the defect fraction. And graph number 4 is the graph of experience and the defect fraction. Clear everybody? Just type yes in the chat box. Clear hai? Clear? So we have to follow these 4 graphs at the bottom. Okay. Now just let's read this first graph. This graph is between defect fraction and the tool aging. On the x-axis, this is defect fraction. On the y-axis, this is x-axis is tool aging. Y-axis is defect fraction. Is it positive correlation or negative correlation? Type in the chat box. Everybody. Positive or negative? Very good. This is called positive correlation, but this is not strong positive correlation because the data is spreaded across. Data ka width बहुत ज़्यादा है. You can see the width of the data is very high, So the spread is very high. So it is called moderately positive, which R square, if I calculate, that R square will be around maybe 60%. It is moderate positive correlation. Clear? It is positive, but it is moderate positive. Now let's come to second graph. Is it positive or negative correlation, temperature and defect fraction? That means more the temperature, more is the defect. Is it positive or negative correlation? Is it positive or negative? Type in the chat box, everybody. Yes. Positive, but stronger than the first one. Exactly. So this is also positive, but R square will be something like 90% here. Are you understanding the difference? 60% and 90%. I'm just giving you just some idea. Okay. Now the third one. This also is positive, where R square, again, it will be around 85 to 90%. Okay. So let's see 90%. Now what about the fourth graph? Is it positive or negative correlation? Type in the chat box. Is it positive or negative correlation? Everybody? एक बार ध्यान से देखो, पॉजिटिव लग रहा है क्या? Is it looking positive? On the x-axis, there are months of experience. So it is showing 15 months and 27 months and 39. So as the months are progressing, is it any impact on the defect fraction? Yes, there is no correlation. Can you see? Now imagine how many times we assume that more the experience, lesser will be the defect. How many of you assume this? Just type yes in the chat box. हम लोग assume करते कि नहीं करते? Just type yes in the chat box. More will be the experience, lesser will be the defect. Yes or no? Everybody? Correct? That's a logical thing. Experience, अगर operator experience होगा, तो defects कम आएंगे. But the data is not supporting that hypothesis. Understand this? Data is not supporting the hypothesis of that. And that is what it is clearly evident. So experience has got no impact on the defect fraction. That is clearly evident. So iska R square value will be around 10% or maybe less than 10%. Clear? So this is how we can do a matrix plot of this. Okay, 1 y and multiple x. Clear hai? Just type yes in the chat box. Now, how can we find out the equation, regression equation कैसे find out करे? Clear है? यहां तक clear है? Everybody's clear with it? Just type clear in the chat box. Everybody, matrix plot clear है? Just think about where you can use this in your company, in your own process. That is more important. Clear? Now let's look at this. Let's look at this, how the equation can be formed. Go to stat, regression, fit regression model. What is the other graphs? Just try to understand this. What is the other graph? This is very interesting. Okay. Now these graphs, let's say this graph. Okay. This graph is between x1 and x2. What does it indicate? As the temperature is increasing, the tool aging also is going up. So this graph is about x1 and x2. This graph is about x1 and x3. Okay. This graph is about x2 and x3. So between x and x, the relationships also are plotted here. And you can check that. So temperature, speed and tool aging has got a very deeper connection. But experience, all the graphs you can see here, this also as well as this also, there is no correlation of experience being seen here, being observed here. Clear? Just type yes in the chat box. So we can drop experience from the model and we can do the remaining thing. Okay, go to stat, regression, fit regression model. Everybody select this. Stat, regression, fit regression model. Now we are finding out the equation. Okay. So response is our tool age, our defect fraction. Double click on the response. Okay. And on the continuous predictors, select tool aging, select temperature, and select speed. Now we need not to select experience because there is no much difference between experience. Okay. So we are dropping experience from the model. So defect fraction is Y, and X1, X2, X3 we have selected as a predictors. Okay. And just say okay. Wow. So you can see here the regression equation. You can read defect fraction equal to Y is equal to A plus B1 X1 plus B2 X2 plus B3 X3. This is called the regression equation of multiple factors, multiple X's and one Y. Clear? Eh? So we have seen how graphically you can represent and how you can make a regression equation model from that as well. Clear? Just give me yes in the chat box. Super, super. Yes. Any question you have, you can just let me know in the chat. See, tomorrow we are going to cover the design of experiments, which is very, very important, and you will enjoy that. Lot of exciting stuff we will cover tomorrow. Now, design of experiment is nothing but it's a combination of hypothesis testing, regression, other statistics. Uska pura khichdi hai, and you are going to. That's what we have taken it step by step. First, we cover the statistics, basic hypothesis, advanced hypothesis, basic regression, advanced regression, and then the design of experiment. So design of experiment is where all these tools are going to be used. Okay. हाँ जी, आर स्क्वायर भी यूज हो सकता है इसमें. लेट मी जस्ट चेक. So you can see here, because we have selected, now understand this, because we have selected the entire three things. Okay, if you scroll it up, you will see the model R square value, which is 98.5%. Okay, 98.5% is R square. Just scroll it up from this equation के थोड़ा ऊपर आपको R square value भी मिलेगा उसका. 98.5% is the R square value for this. So very strong correlation, because we have eliminated the experience, right? अगर एक्सपीरियंस ऐड करेंगे तो आर स्क्वायर वैल्यू थोड़ा सा कम हो जाएगा, बिकॉज एक्सपीरियंस का इंपैक्ट ज्यादा नहीं है. क्लियर? Super. If you want the individual R square value, then you can plot individual graphs. What is the R square between temperature and defect fraction, speed and defect fraction, etc. Tool aging and defect fraction. That you can individually also, you can create the graphs as well. Okay. Superb. Yeah, 98.2. Yes, correct. Clear, everybody? Just type yes in the chat box. So that's it from today's point of view. We will continue our journey from tomorrow and we'll cover design of. See, we are only covering the topics which are deeper, which are not covered in the green belt. Okay. Those topics are only covered in the black belt hackathon. Clear hai? Superb. Enjoying or not? मजा आ रहा है कि नहीं आ रहा है? मजा आ रहा है ना? Yes. That is the most important thing. See, enjoyment and learning is the most important thing. Okay? Superb. Yeah, relationship is very good. Absolutely. And it is clearly evident. Na? The R square values are clearly evident. 90+% R square values. So very strong correlation between these factors and the defect fraction. Okay? Superb, guys. Thank you very much for joining in. It's already 9:30. So we will conclude today. We'll connect again tomorrow with design of experiment. We'll recap tomorrow for whatever we have seen for 2 days. and then we'll go for the design of experiments. Now, the people who are done with the green belt certification and completed their study of black belt should attempt the examination tomorrow. If you have not been through the black belt content yet, please do not try to attempt the exam tomorrow. The fear is not to fail the exam. The fear is to clear the exam. Understand this? Okay. So what is my worry? My worry is not that you will fail the exam. My worry is without study also you might clear the exam. Okay, and that is my worry. Then you will never take the check the curriculum and content and never study. So only the study is completed, only you have been through the hackathon, then only go for the examination. How many of you will go for the examination tomorrow? Just type me in the chat box. I'll explain you the procedure, etc. tomorrow. Okay, tomorrow you can go, or maybe after 1 or 2 days. Correct. Do not hurry, do not rush into certification. Certification everybody is going to get, but our learning, deepening the knowledge is very, very important. Okay. So you decide, you check your confidence level. If you have been through all the content and you're very clear about each and every element of the content, then only I would highly recommend to go for the examination. Okay. Yes. Super. So let's call it a day. Thank you very much for joining, and we'll connect again tomorrow with a recap and design of experimentation and the examination. Okay. All the best. Keep learning, keep growing. This is Dinesh Patil signing off. Bye bye. Take care.